Okay, today's lecture is on software lifecycle models. So basically, we will start with the uh, classical waterfall model. We have covered the topics in my previous lecture, like different phases or the activities of lifecycle model, and we have discussed about problem definition document. We have discussed about feasibility study report, and then we have discussed about what are the various sections under a particular software design document. So so the first uh, the first software development model is a classical waterfall model. So so here in this model, so whole life cycle is divided into a few number of phases, and these phases are feasibility study, requirement analysis and specification, design, coding and unit testing, integration and system testing, maintenance. So we'll talk about all of them one by one. So here you can see different phases are executed in a linear fashion. You can see unless or until the requirement analysis phase is complete, so you are not allowed to go into design phase, or the feasibility study phase. If the feasibility study phase is not completed, then you are not allowed to go into the requirement analysis phase. So these phases are executed one after the other in a linear fashion. So feasibility study, thereafter requirement analysis, so then design. So you can see something like this. I mean, if water falls from a particular hilltop, so slowly it is going down. Okay, so water flows from hilltop to the bottom of the hill. Okay, so here that is the reason why. So name is a name. The name given here is waterfall model. So you can see the water flows from one phase to the other phase. So this way, right? So activities are carried out in this fashion. So we start with the feasibility study, then we are going into requirement analysis, then we are going into design, and then coding, and finally you are reaching to the maintenance phase. This is what as I already explained you. So there are each and every step or the phase that takes some input from the previous step and gives output to the next step. And now you can see. So let's say if you see requirement analysis, so it takes the input, which is a output of feasibility study, that is given as an input to the requirement analysis, and by taking this input, now it is producing a output, and that output will be given to the design phase, that will be given as an input to the design phase. So exit criteria of a step must match with the entry criteria of succeeding step. So here you can see, so like the exit criteria, unless or until the exit criteria of this feasibility study is met, you are no way allowed to go into requirement analysis phase. That means the input, the entry criteria of this requirement analysis should match with the exit criteria of feasibility study. Then only you can initiate this requirement analysis phase. Otherwise, it is not possible. It follows specified design build sequence that is intuitively obvious and appears natural. Okay, so after that, usually we going through a specification. So we started with like once the requirements are gathered here, okay, and specified, then only we are going into designing phase, and then you going into coding phase, and then testing, and finally maintenance. It produces many intermediate deliverables, usually documents. So these are the documents, usually, as I told you. So each and every phase produces some some artifacts or the deliverables or the output, and these outputs are provided in the in some standard formats. Like as we already discussed, software design document. So that software design document uh, actually produced from the design phase, and it has certain number of sections, and that means a standard format is given, right? Act as a baseline used as a reference for contractual obligations of user for maintenance. So it is, I mean, this is this particular document. These documents can be, used as the baseline. Okay, because once the, let's say, SRS is one of the software requirement specification document, is what comes out of a analysis phase, requirement analysis phase, right? And whatever the requirements are, uh, you know specified in that particular document, now they will yeah, used for contractual obligations also, right? That means at later point of time, once the if the software is delivered to the client, and later point of time, client should not say, I have certain set of requirements which are not met by the delivered software. So this shouldn't happen, because every requirements has been specified correctly in the document, and now this is it's a baseline document. Okay, important for quality assurance as well as project management, etc. So because these documents will be uh, exchanged by different development team members. So if we have certain number of documents, that means, let's say, for example, if you have created the documents, so these will be used during maintenance phase. So when there are certain number of people who are going to maintain the software. Actually, they are not the people who develop the software, but now they are going to maintain that particular software. So if you have a document, if we have a document, then it will be easy for them while maintaining that particular software or carrying certain maintenance activities for that particular software. Now, as I said you, so these are the different phases. So you can see the first phase here is the soft system engineering. So usually, problem definition and usually it comes under the system engineering, as well as you can say the feasibility study. That will be also part of system engineering. We have already discussed about computer system engineering, whereby we have already discussed. So usually problem definition and feasibility study can be part of a system engineering. So usually, so the main goal of this particular phase is to identify overall problem. What is the problem exactly we are going to take up, or that development team is going to take up and solve that particular problem. Here it establishes requirements for all elements of the system are to be developed through the software. That means here we try to establish what are the various requirements that needs to be handled through the software we are going to develop. And also we try to identify what are the functions that cannot be performed by the software, and what are the functions that can be performed that can be performed by the software. Let's say there are certain functions which need the human intervention. Let's say, for example, we take an example of a ATM machine, automatic teller machine. So where now you wanted to withdraw money from the ATM machine. So what you try to do, you first trying to, you see, you need to insert your debit card, and thereafter you will have to enter the PIN, right? So entering those PIN and inserting the card, it should be done manually. Okay, it cannot be automated. I mean, these sort of activities or the functions or the actions that need to be carried out manually. So this way you need to understand what sort of activities that can be handled manually and what sort of activities that cannot be. That should be handled by the software. When the requirements are clearly defined, waterfall model is the ideal model for deployment. So its assumption is that if the requirements are very clearly defined, so it has no ambiguity. So there is no inconsistency in the requirements. So everything is clear to the customer as well as the developer. So in that case, we go with a waterfall model.
Sir?
Yes, Rohit, you want to ask something?
Yeah, so system engineering is same as like feasibility study before the
Yes,
mains
yes, yes. So system engineering is something where we talk about how we're going to define the problem. We are going to define the problem as well as we going to the feasibility study. Okay, so these can be part of system engineering, right? And we also seen, right? Whatever the tasks or the functionalities of a particular system, so those tasks should be here classified, right? So what sort of tasks can be handled by the software and what sort of tasks should be carried out by the manually or by the hardware. Okay, so this way we try to classify various tasks, right? Is it
Okay.
clear?
Yes, yes.
Yeah, we already talked about this during computer system engineering, right? So that is what. So, and then you have a analysis phase and project planning, and then design, coding, testing, installation, and maintenance. So we'll talk about that. So the next phase here is analysis and project planning. So here the part of analysis phase, what we try to do is we try to understand the information domain. That means what data is to be used. You try to understand the domain, right? Let's say, for example, you are going to develop a software for banking, right? So what sort of data that will be given as an input to the system and all. So these and what sort of output that is going, what sort of output that is going to come out from the software, so that needs to be understood, right? So, and what function is to be performed, that means here what are the functions that need to be performed by the system. And if at all any performance, you can think of performance in terms of the number of transactions in terms of, in case of banking. So so how many number of transactions being handled by the software at some point of time, so that can be one performance measure, right? So I know if at all you are concerned about the performance, so that will be analyzed here, as well as interfacing requirements. Let's say, for example, let's say you talk about any uh, any software like Amazon. Okay, so where you try to buy certain items, right? Now your Amazon software provides you a cart where you select certain number of items and then you put all your items in the cart. And now once you finalize that these are the items that you wanted to buy, and then going through purchasing that particular item, now your Amazon software exactly creates an interface with some sort of banks, right? Because you are going to make the money transactions through banks, right? So for this particular software, you may have some sort of interfacing with any other software also, right? So you can think of like that can be one, or you can think of what sort of interface that you want, how you going to input your data. So So these sort of requirements will be analyzed here during part of analysis phase. Okay. And clearly define, identify the requirements which are to be met through the development of the software. Okay, so here, we are trying to identify as well as define all the requirements which are to be met through the software. Now, let's say if the project is very large, then what we can do is now the project planning step can be it can be made as a separate phase. Okay, if the project is very small, then you can place this project planning phase with analysis phase also, right? So main objective of this project planning phase is to I mean identify what are various deliverables that should come out of these phases. Okay, that means what are the artifacts that should come from each and every phase. Okay, so how the project will be carried out, how this project will be executed throughout its life, what are various steps, that means what are different phases you really require. And I mean, how much time each and every phase is going to take, and what resources really we need during each and every phase. So these sort of all things will be planned during a project planning. Okay, so any doubts so far, Prajna?
Sir, sir, feasibility study stage comes before requirement analysis or after requirement analysis?
Before requirement analysis, feasibility study. Yeah, because that is related to business applications, I mean business analysis. Okay, so we try to see whether the proposed alternative solutions, whether they are feasible or not. Okay, once they are feasible, then that is done through that may be done in 1 or 2 days. Okay, once those things are carried out, then we are going into you are going into requirement gathering. We try to gather the requirement, and then we try to analyze those requirements, and then you need to specify those requirements. Okay. Yeah. So during requirement analysis, what we try to do, so ultimately we are trying to establish the requirements. Okay, so that is what we try to do here. But feasibility study, we try to see whether the solutions, so high level solutions, whether they are feasible or not, whether they are financially worthwhile or not. So those sort of things will be carried out during feasibility study, and that will be before the analysis phase. Okay.
Sir, unless we get to hello, sir.
Yes, tell me.
Sir, unless we get to know our requirements, how will we able to design a software or any system? And before requirement analysis, how we can study the feasibility of this system?
No, actually, so you see, usually, part of requirement analysis, we try to find out the actual requirements of the customer. Okay, actual requirement where the requirement is not clear. Okay, so now that should be analyzed, right? But before that, let's say for example, you can think of like this. You I as a developer and you as a client, for what, for let's say you wanted to get developed a software which can handle student registration process of your institute, student registration process, right? Now from as a developer, I will first maybe so we try to finalize whether I should go with the development or not. So in discussion with the customer, so we try to define that particular problem. Okay, whether it is a problem or not. So student registration process is a problem or not. So that will be first established. Okay, that will be carried out during problem definition, as I already discussed during these phases. Okay, once that is we usually the, let's say for example, you I mean you as a client, so you will invite a person from the industry, and then that expert will be going to your workplace, and then they now in discussion with the client. So we try to establish that that's as a problem first. Okay, if that is a problem, okay, now what will happen? So then the expert will carry out somewhat it may be it may not be the complete estimation, but it may be a rough estimation, right? So these are the alternatives we have, actually one or two or three alternative solutions, whether you wanted to go with all these things, right? So those sort of things will be carried out, right? Based upon that, a design, a alternative is chosen, and thereafter what will happen? So usually analyst will come into picture here. We try to gather the whole requirement. Thereafter we'll come to your place, and then going through certain interviews and all. So we try to understand actually what are the various activities that are carried part of any student registration process. I mean, how this is going on. So then we will understand the whole system. Thereafter, once the requirements are specified, then we will be going into design. Is it clear?
Yes.
Prajna?
Yes, sir. Yes, sir.
Yeah,
Hello?
I think you are not audible. Maybe internet problem.
Sir, actually, the weather here is so bad, so
Okay.
that might be the problem. But
Okay.
I got it, sir. Fine,
Yeah, okay.
continue.
Fine, fine. Now, so part of design phase, what we try to do, whatever the requirements are there, so those requirements, I mean, whatever the requirements are specified in the SRS, now those requirements will be translated into some implementation framework, and that will be implemented during the coding phase, right? So usually what will happen, whatever the requirements we have collected or the specified, those requirements will be converted into software architectures, where we have already talked about the software architecture, right? Where we try to whole system, large system will be decomposed into certain components. Okay, I mean subsystems, right? And so now those subsystems will be will be defined, specified. I mean, what sort of algorithms really required. I mean, what sort of data structure really required in order to implement that particular data, I mean, module or the subsystem, right? So those things will be uh, carried out part of any software architecture, right? So as well as, so maybe I mean, these requirements will be converted into some sort of database design. Okay, so after the requirements, so we try to convert some sort of into some sort of database, right? So that will be done part of any design phase. So divided into high level and detailed design depending on the complexity of the task. So sometimes the design phase may be divided into high level design as well as detailed design. If the complexity of the problem is very high, or the complexity is very high in that case, so we divide that into high level and detailed design. As we already discussed about high level design and detailed design before. Now there is a coding phase, so it is all about programming, right? Whatever the once the individual modules are specified during a detailed in a detailed design phase, Now these modules will be implemented using some programming language. Okay, so they are so this particular phase will produce some piece of code, source code. Now the next phase here is testing. So here what we try to do, let's say, as I said you, so we have, let's say you have implemented all the modules, right? So after implementation of each and every module, so you carry out a testing. So usually you test first the logic of individual module, right? And when we put all of them together, then we want to test interfaces so that they work collectively, that they are intended to work. That means first what you try to do, you try to test individual modules, and after integrating those modules, you try to you try to test the interfaces between those modules, so that whether after integrating all of these modules, whether is there any problem in the interfaces, right? So that is the reason why you try to test the interfaces. And then you have a finally you have an installation and maintenance phase. So where what we try to do, you once the software is developed, now you will deploy that particular software at the client side. um, if you encounter any error, or if at all the user is experiencing any errors, then you need to make necessary changes so as to correct those errors. And finally you try to review for the performance, whether the performances are met or not. If the performance is not met, so in that case you need to report it. What is, you try to make changes so that the performance should be achieved up to the mark. So now we talk about different deliverables. That means, as I told you, so each and every phase produces a document or a deliverable or an artifact, right? Now, what are those artifacts? We will see one by one. So one artifact that comes from is a project plan, right? So it may be modified at later time. And feasibility report, as I told you, so project plan and feasibility report. So where part of feasibility report, um, you know it is what mentioned whether the investment we are making, whether it is a worthwhile or not, whether we are going to get some benefits or not, whether the benefits may be in terms of tangible benefits or maybe in the intangible benefits. That means you see directly the benefits or you see those benefits indirectly. I think we have already discussed about those benefits, what type of benefits and all, when you were talking about the phases. So those things are exactly part of any feasibility report. And there is another deliverable called as SRS, software requirement specification, right? So it is an important baseline because so this document will be considered as a contract between the client and the developer, right? So defines the functions that the software will perform for us, right? That means whatever the functionalities need to be met through the software are mentioned out, are specified. This SRS output that comes from the analysis phase. So this document comes from the requirement analysis phase, right? Then you have a system design document. So it is an output from the system design phase, right? So where it defines the different components of the software. That means it will define what are the different modules of that particular software, and how these modules will be implemented are also specified, right? And part of detailed design, so what you try to see, you will try to see the individual units of the modules, components, so which will be directly implemented by a programmer. Okay, so that is what exactly part of detailed design. Now, the other deliverable here is a test plans and test reports. So usually test plans are made in advance and test plans are carried out as soon as the software is ready, right? So usually, so how you going to test those, software, going to test that particular, those, modules or the software, so as a whole. So those test plans are carried out in advance. Okay. So once the software is, once the software is developed completely, now we apply those test cases, right? I mean, let's say if you have developed some test cases, okay. I mean, you now try to develop some test cases and then you will apply those test cases here during the testing phase. So here what input should be given to the system, what outputs are expected, right? So this is what exactly part of any test cases, right? So what is the input should be given to the system and what are the outputs expected, so that will be observed here. I mean that will be taken into account, whether the expected outputs are correct and the performance is as expected, so those things will be reported out here. Okay, so I mean when you give the input to the system, right, so whether we are getting expected output or not, whether those outputs are correct or not, so everything will be mentioned out in the test reports. Okay, and then the other deliverable here is a source code. It is in the form of executable, unlike other deliverable that comes in the form of documents. So as I told you before, so other phases of this waterfall model produces some documents, whereas the source code phase it produces uh, the deliverable in the form of executable. Maybe it is in the .exe format, right? Because so the source code, that's a program written by the programmers, right? So that is what the deliverable comes out from this particular phase. And you have a software manual, right? So that's a user manual. That means so how the user is going to use and what are the benefit, what are the complete description about each and uh, every functions of that particular software, right? How you going to install them, so every instructions are provided part of any software manual. And then finally there is a review report, so that review reports will come after each and every step. So we try to identify the shortcomings, defects, uh, which are maybe the defects are detected, whether those detected defects are properly addressed or not during each and every phase. So those things will be reported in the review reports, a catalog of how development went through. I mean, how the activities are carried out. Okay, uh, from each and every phase, how the activities are carried out. So those things will be mentioned out here. It is an important input to the management and development team, because review reports are the one which are meant for the management, because the management is going to invest more, I mean is actually investing money in this particular project, right? As well as the development team who are actually involved in developing the software, right? So they are more of interested, whether the progress is going as per the schedule or not, right? Whether any defects are whether the defects are corrected properly or not, if at all any defects are there, right? Whether the development is going as per the milestones defined. So those sort of things, everything will be whatever the reviewed are part of this review reports. So now we'll see how this cost or the effort that is actually distributed among all the different phases of this model. So usually the cost from, when you are going from the system engineering to the maintenance phase or the installation phase, right? So the cost of the cost actually increases dramatically, right? Because the programmers, operators, various technical writers, computer time have been committed. Okay, because you see, when you're going from the system engineering phase to the maintenance phase, so slowly the people are, the number of people working towards the software developments are increasing, right? Let's say for when you are at the analysis phase, maybe there are only analysts involved. Now when you are going into the design phase, so then designer will also come into picture. Now after, when you are going into the coding phase, now the programmers will come into picture, right? So that means slowly people are increasing, right? So that is the reason why, so the cost is also increasing, and also effort is also increasing, because the time we are putting onto developing that particular software is also slowly increasing, right? So that is what we try to say. We need to fix the errors as early as possible, because everyone has spent enough time, right? So wherever that particular error, let's say if there is any error in the analysis phase, so if that error is corrected there itself, if the error is corrected there itself, if the error is detected there itself and then corrected there itself, then it will be beneficial. Otherwise, what will happen if that error is detected during programming? What will happen now? So I think you have made already, you have designed the software, right? So you have to do so many rework, like, in order to correct those errors in the requirement phase. So accordingly, you need to make changes in the design, as well as accordingly you need to make changes in the source code, whatever till now you have produced, right? So that means, so if the error is detected there itself, then it is better. Okay, but if the error is not detected, then actually the cost of development will increase. Okay, so usually, so more cost is required for detailed design, implementation and maintenance phases. And cost of discovering and fixing errors also increases with steps, right? So finding out, detecting an error and fixing those errors also a difficult task when we are moving from the system engineering phase to the maintenance phase, right? So it is, that means it is, we can easily find the error there itself in that particular phase only. But if that error, you want to discover that particular error in later phases, so it is little quite difficult. So requirement may not be, so then so what is the shortcoming of this waterfall model? So as I told you before also, requirements may not be clearly known, especially for applications not having existing manual counterpart. That means, so we assume that the waterfall model will be applied when the requirements are very clearly known. Okay, but if the requirements are not known, then this particular model cannot be applied. Let's say, for example, so let's say you are going to develop a software for which there is no manual counterpart. So no manual system is existing. Then that means the requirements, definitely the requirements are not clearly known. Okay, now you can think of you going to develop a software for an institute, where how you going to, we wanted to automate the students registration process. Okay, so now you see in our institute, let's say you are going to develop for our institute, so we have a manual existing system. Okay, so I mean you can take out a form and you can mention all different courses whatever you wanted to do, wanted to take, wanted to register, so and then get it verified by the faculty advisor, and then can be sent to the sent for the HOD of the department, and HOD in turn after signing it may be sent to the Dean Academics Office, right? So now there is a manual existing procedure, okay, that is well defined, that is existing. Now, then you wanted to develop a automated software for this process. It is easier. It is easy for you because the requirements are known. I mean, this is what exactly happens in the existing system. But if at all, if this existing system is not there, then what will happen? So that means the requirements are not clearly known. I mean, who will first, write that registration application, and then who will verify that application form, and whether it needs to go through HOD or not, that is not known. Whether, these sort of, requirements are not known. Okay, then probably waterfall model is not applied, cannot be applied. Okay, so you can see something, an example, you can see railway reservation. Okay, so there is a manual system, right? So where, if you wanted to book a ticket, so you can go to the you can go to the railway station, you fill out the requirements, what is that, in which train you wanted to travel, from where to where you wanted to go, how many number of people you are trying to, going to travel. So every details are provided through a form, and then that form is submitted to a personnel, then that particular person will person will book a ticket for you, right? So there is a manual existing system. Okay, then the requirements are almost known. Okay, so then those requirements may be defined in the SRS, then it is fine. You can you can develop the railway reservation software. But let's say there is an online container management for railways. Okay, so you can think of online container, maybe anything like let's say railways handling goods, movement of various goods, right? So you can think of like, so you wanted to move certain goods from one place to the other place, right? So in between they have certain number of containers, right? So the trains are, these goods trains, they going to pick certain items from different containers, and then they take into a different place, and maybe they will be again downloading those goods into a container, right? So from there, another train may take those items from that particular container. You can think of like this. Okay, so let's say that is completely new. Okay, that is not, there is a manual there is a no manual system existing. Okay, so in that case, so it is quite difficult for us to go with waterfall model. Okay, maybe you can think of knowledge management for central bank. So you wanted to create some sort of knowledge management, that means where you share some sort of knowledges between the banks, or you can think of, right? And if let's say this is completely new software that you are going to develop, right? So in that case, so it is quite difficult for us to go with waterfall model. Now the other shortcoming here is, so according to this model, so this model assumes the requirements are stable. That means the requirements are not going to change over time. But this as a it's very difficult in these current these days, right? Because the requirement always changes over time. So users may find a solution of little use, right? So because you can think of something, if the requirements changed, now you have developed a software, and then what will happen? Usually that software will be useless, right? No one is going to use because the requirements are changed. So better to have development in parts in smaller increments and get the feedback from the user. This is common for packages, system software. Let's say if you can have the system developed in parts, then it will be better. You develop the you develop the whole software in increments, right? So you develop the first increment and then deliver to the client, let the client use, okay, for sometimes. In meantime you develop the other parts, right? So this is the way that you can develop the software. That means you can see something like this, right? So whatever the requirements that are maybe some of these requirements should be given very priority, okay? These are very urgent, okay? So these requirements are required at that point of time, okay? So then you first implement those requirements and then give it to the client, let the client use, okay? Otherwise what will happen? By the time you developed a software and if that requirement has changed, then what will happen? So then it is no way useful for them, right? So and why this is happening? Because you see some softwares development takes even 2 to 3 years, okay? It's not that today you given your requirement, tomorrow it is developed. It is not like that, okay? So within a year or so maybe our requirement changes, right? So that is the reason why the require, if you can develop in smaller increments, what will happen? At least the client might at least the client gets as much as its benefits, okay? uh, so if you deliver the prioritized requirements. And the another shortcoming out of this model is it is a documentation heavy, because it creates so many documents, right? So each and every phase, actually except the source code phase, coding phase, so all other phases produces number of documents, right? So what is said is, so for some sort of projects, for some projects, maybe these many number of documents, documentation are not required. So that may be one shortcoming of this model. Now, as I told you, so uh, out of all of these phases, so the maintenance phase actually requires maximum effort. And you can see there, right? Maintenance takes almost 60%, testing takes almost 20%, coding takes more than 10%, and design takes almost 10%, right? Requirement specification takes 1 or 2%, right? Now you can see, so the development phases, among the development phases, that means the requirement specification to testing, so they are the development phases, right? So among these development phases, testing takes more effort, requires more effort. And if you see, among the life cycle phases, that means among all of the phases, so maintenance requires, consumes maximum effort, okay? So usually your this is a way that you can understand, right? So most organizations usually define standards on the outputs, deliverables produced at the end of every phase, right? So now, as I told you, so these the artifacts or the deliverables that comes from each and every phase should follow some sort of standards. Or you know, as I told you, they are provided in some standard formats, right? As well as entry and exit criteria for every phase should be met. Okay, so those things, you know, these things may be defined by each and every organization. So they developing a software. They also prescribe specific methodologies. Sometimes, you know, each and every organization can provide, if at all they have their own methodologies for developing, you know, each and every phase. Let's say, for example, for specification, if they have any methodologies of their own, so they can also prescribe, right? And for design also, let's say if they have any methodology, right, so that can also be prescribed, right, for project management, etc. Okay. Now the guidelines and methodologies of an organization called the organization software development. Okay, so usually, as I told you, so the organization may have their own methodologies as well as the guidelines for development of any software, right? During each and every phases, maybe they have some sort of guidelines, right? So that is what we call a software development methodology. Usually whenever these fresh engineers, so they join the organization, right, the software development organization, so usually they should master this organization's software development methodology. So because they are the one who is going to develop the software, right, so they actually need to get the training on uh, the software development methodology. So now we'll talk about the feasibility study phase. Okay, so what we try to do, so part of feasibility study, so we try to determine whether the developing product is financially worthwhile. So that means the investment that we are making, so we are whether going to get good benefits out of it or not. So whether this is financially worthwhile or not. So that is what exactly determined. As well as we see whether the software solution is technically feasible or not, whether the alternative we have chosen, so whether it is feasible or not, right? So first roughly understand what customer wants. So usually part of this feasibility study, what we try to do, we go through a rough understanding what customer wants. Okay, different data which would be input to the system, like what is the input that will be given to a system and what is the processing needed on these inputs, right? I mean, what is the input to a function and what is that particular function and what is the output that could be produced by the system, right? And if at all, you know, if it has any number of constraints on the behavior of the system, okay? I mean, if at all it has any constraints, so those things also should be understood during this particular phase. Work out an overall understanding of the problem. As I told you before also, here we try to understand the important requirements of the customer, right? So but here's like screen layouts or specific algorithms required or database schema to be used, so they should not be um, discussed here. Okay, so where we try to discuss all these things, like what sort of screen layout you need, what sort of specific algorithms required, where we will discuss these things. Prajya?
Yes, sir.
So where we discuss these things, specific algorithms, what sort of algorithms will be required, what sort of database schema that we will require.
In the design phase.
Right. So we will discuss all of them during design phase. That is why. So here we try to understand only the requirements. Okay, important requirements. Right. So that will be part of the problem. Right. And then formulate different solution strategies. Maybe whatever the requirements you have. I mean whatever the problem that we have. So for which we try to come up with the high level solutions. Let's say maybe it is a client server framework or standalone framework. Let's say you can think of, right, whether the software that you going to develop, whether the client and server will be within the same system, or the client and server will be part of different systems, right? So that sort of solution schemes, if you have alternatives, so that should be explored here, whether you need to go with a standalone application or you need to go with a client server, right? So now you can think of like Amazon is a client server based, right? So you as a client and Amazon will have a server, right? You put your request and the server will serve those requests, right? And similarly you can have a software which can be running within the same system. Okay, so that can be explored. Okay, so usually we try to examine all these alternatives, okay, in terms of what the resources required, what would be the cost of development, and how long time they take to develop. Okay, so based upon these three parameters, we give some sort of recommendations, right? Whether we need to go with the alternative 1 or 2 or 3. So if you're going with the alternative 1, the resources will be required are this, cost will be this, and development time it will take is this. Okay, this way, right? So usually you try to perform cost benefit analysis. So to determine, I mean, what is the solution is best, right? Because we try to see whether we are going to get any benefit out of it, this or not. As I already discussed this cost benefit analysis during the feasibility study phase separately. So maybe in the previous lecture I talked about this, right? You may determine that none of the solution is feasible due to high cost, resource constraints and technical reasons. If at all you think that whatever the alternatives that you have, they cannot be feasible because of high cost, okay, or maybe you have certain number of constraints, okay, resource constraints, right? Or maybe yes.
Sir, are you sharing your screen also?
Yes, I'm sharing.
So, sir, I am not able to see your screen.
Okay. Anyway, so you see, you can. I will share my slides. Okay. Later on, you can go through those slides also, right? Huh? So as of because almost I about to finish the lecture, right? So because I cannot reload again. So I think you can see the slides. I will share these slides. Okay. Okay.
Fine, sir, continue.
Okay. So usually part of this feasibility study, we try to go through this cost benefit analysis, right? And this can be, sometimes you can come up with a recommendation that none of the solution alternatives are suitable at this point of time because of high cost. You have certain resource constraints, okay? Or let's say, for example, we come up with a solution which requires a Windows operating system. Okay, now that Windows operating system is not available in our institute, or I mean that is not available with the client side, right? Now that means client has to buy that operating system. Whoa, then what will happen? So you will not be able to develop that Windows based solution, right? Because the client has no money to buy that Windows operating system. You can think of like this, okay? So and that any technical reasons, right? Maybe the technology may not be able to uh, you know cope up with the requirements, right? So all these things can be uh, analyzed. And then you have a requirement analysis specification phase. So ultimately, the main aim of this phase is to understand exact requirements of the customer, right? And then you document, that means you specify those requirements properly, right? So, and usually this requirement analysis and specification phase carry two different distinct activities, and these activities are one is requirements gathering and analysis, and the second one is requirement specification. First you need to gather the requirements from the client, okay, and then you need to analyze those requirements so as to define those requirements very precisely, correctly, without any ambiguity, or should not have any, right? So, and then you need to specify those requirements in such a way that so it should not have should not have different interpretations for each and every requirement specified. That means it should be it should not be it should be unambiguous. That means it should not be there should not have any ambiguity. As well as it should there should not have so requirements should not be requirements should be specified consistently. That means at one point of time you are saying something and the other point of time you saying something else, right? So they should be consistent also, right? And the requirements should be very uh, precisely specified during requirement specification. So part of requirement analysis, first what we are trying to do, you try to collect the data from the customer. So, and then you try to analyze the data that you collected so as to understand what the customer wants, find out any inconsistencies and incompleteness in the requirement. That means, as I told you before, so if at all any inconsistencies are there, so you need to resolve there. You need to find out those inconsistencies, and sometimes if some requirements are missing or requirements are omitted, so so that is what you need to find out. Resolve all inconsistencies. Requirement contradicts. Let's say at one point of time you are saying something and the other point of time you saying something else, okay? So if at all those inconsistencies are there, so you try to resolve them, right? If any requirements are missing also, so you try to find out them during this. So the requirement gathering usually involves, so we collect the requirements from end users through interviews and discussions. So you will interview the client or the users who are going to use the software, right? And so you carry out certain number of discussions so as to collect the data. Okay, let's say for example you see you going to develop a business accounting software. In that case, what will happen? You will have to interview all the accountants of the organization, right? You will talk to them because they are the one who is going to use the business accounting software part, right? So this is the way that you can understand. The data you initially collect from the users would usually contain several contradictions and ambiguities. Each user typically has only a partial and incomplete view of the system. Now you can see why this data will contain more number of contradictions and ambiguities. The reason is that so the users they will have typically a partial view of the system or incomplete view of the system. Now you can think of let's say our nitrate system, okay? So now I am a user of the nitrate system, but my role here is a faculty. Now you as a user, your role is student, right? So similarly, there are maybe in the account section, so there are accountants, okay? They are the users. So now accountants are going to use that particular portion, they are going to use that particular portion in the NetRes software. Similarly, as a faculty, so I use my relevant, functionalities. So as a user, as a student, you will be, given certain access, right? So that means, so you always have a partial view of the system. That means you do not have a complete view of the system, right? So you will be giving the data from your point of view, okay? And I, as a user, I will give my data from my point of view, right? So that is what happens, right? So now it is it is now the duty of the analyst to find out the inconsistencies, okay? So we have given all requirements. So now after collecting those requirements, they need to find out inconsistencies or incompleteness at all available in the requirement specification. So requirement analysis. So usually, if at all any ambiguities, contradictions are there, so they must be identified and they should be resolved in discussion with the customer. Okay. So these requirements are whatever the requirements we gathered, so they will be organized in the form of software requirement specification document. Okay. So this activity is actually carried out by a engineer called as analyst. So usually the analyst who is going to specify all the requirements. Okay, after having number of discussions with the users. Now you have a design phase. So usually, as I told you before, so this phase transforms the requirements into a implementation framework. So now that implementation framework will be directly implemented during the coding phase by the programmers using a suitable programming language. Okay. So usually part of design phase, so we'll see some sort of software architecture, right? So whole system will be decomposed into subsystems, and those subsystems will be further decomposed into subsystems, right? So ultimately we can see in terms of different modules, of a particular software, right? So it exactly applies to design approaches. One is traditional approach, the other one is object oriented. So part of traditional approach where we see we have a number of functions. Okay. Now, so it is a procedural, approach, right? So where we try to have certain number of procedures. Okay. Whereas in case of object oriented approach, so usually the main so important unit of this object oriented approach is the objects, right? Or the object structure. We'll talk about them, right? So part of traditional design approach. So again, you have two different activities carried out. So one is structured analysis, the other one is structured design. So part of structured analysis activity, what we try to do, we try to identify the functions to be performed. So here we try to identify what are the different functions, right? So and then we try to identify the data flow among those functions. Okay, how the data will be flowing from one function to the other function, right? So if you have a function, if you try to decompose that function recursively into sub functions, okay, so in that case also you need to identify the data, how the data will be flowing among those sub functions as well. Okay, so now you can think of, right, let's say you're going to develop a factorial problem, factorial of a number using recursion. Okay, so that factorial problem using recursions, that means recursively you calling sub functions, that means that factorial function, right? So you will be calling recursively, right? In that case, how the data will be flowing from those sub functions among those sub functions also should be defined. Okay. So usually these structured analysis is carried out using data flow diagrams. We'll talk about this data flow diagrams when you are talking about the, maybe after a few lectures, right? So by using these data flow diagrams, we carry out this structured analysis. After structured analysis, carry out the structured design. So part of structured design, exactly we will get these are the two deliverables. One is, as I said, you architectural design or the high level design, and the second one you going to get here is detailed design or low level design. So part of high level design, um, you will be talking about different components, okay, and part of detailed design you will be talking about what sort of data structure, algorithm, each and everything required for each and every component. So that will be specified during detailed design, right? So part of high level design we will see whole system into modules that, and then how these, I mean, what is the invocation relationship among these all modules. So what module is going to call which are, what other module. So those relationship also are defined, okay, during high level design. Whereas in part of detailed design, so we'll specify, for each and every module, what is the data structures or algorithms will be used, okay. So they are designed. And the other one here is the object-oriented design, where we first we try to identify different objects that are occurring in the problem. I mean, you need to find out the relationship among these objects. So let's say you take an example of a payroll software where employees, manager, payroll, registered department, they are all the real world entities. Okay, I mean they exist in the real world, so they can be considered as the objects, right? So now, so here we try to identify the object structure, right, as well as I think so. I stop here at this point of time. So as I already discussed, no, I already discussed about this object-oriented design in the subsequent lecture. Okay, so I stop here. Prajna, I'm going to stop the recording.
Yes, sir.